The Fulda Lakes have been a priority for the Heron Lake Watershed District and our partners for many years. The relatively small watershed to receiving basin ratio has given us the opportunity to provide treatment to the majority of the water entering the lakes. More importantly, it has allowed us to see positive outcomes as a result of the projects and education implemented. Without partnerships, this project would not have been successful. Fulda Lakes are comprised of 2 lakes. The south is called First Fulda, the north is called Second Fulda. This map shows the area that drains to the lakes. The blue line is the subwatershed that drains directly to Fulda Lakes. The yellow line is the watershed district boundary. Judicial Ditch 13 is the main source of water to the lakes. These are the locations of the projects that were implemented. In the spring of 2002, JD 13 was improved to an open ditch to address inadequate drainage. The watershed district required landowners to install buffer strips along the ditch. A majority of the open tile intakes were replaced with rock inlets through a 75% cost share program. The watershed district required the runoff from JD 13 to be filtered before entering the lake. We purchased property and restored a wetland directly below the ditch system. Water from JD 13, along with a 12-inch stormwater outlet for the city of Fulda, flow through the wetland before entering the lake. Directly below the wetland is Schindler's Pond. This pond was in place before the ditch improvement. Its original depth was over 5 feet. In 2006, the pond held only 8 inches of water. It had kept nearly 5 feet of sediment from entering the lake. To provide treatment for stormwater entering from the southwest, Murray County, Fulda Fish and Game, the U.S. Fish and Wildlife Service, and the Watershed District partnered to install the Murray County Pond. This pond is placed at 0 grade to allow sediments and nutrients to drop before entering the lake. This was completed in 2009. In May and June of 2010, we collected water samples at 4 sites. Water outletting from JD 13 before any treatment, below the wetland restoration, below Schindler's Pond, and at the end of the Murray County Pond. This graph indicates the different concentrations of total phosphorus, total suspended solids, and nitrogen. The water entering from JD 13 was pleasantly surprising. For example, the water that passed through our Jack Creek sampling site entering North Heron Lake typically has around 100 to 200 milligrams per liter of total suspended solids. The water coming in from JD 13 was below 11 milligrams per liter. Total phosphorus entering at a very low amount of 0.05 milligrams per liter and entered the lake at the same. The nitrogen decreased slightly as it passed through the treatments. The exciting part was the total suspended solids. They entered at 10.67 milligrams per liter and left at 2.67 milligrams per liter. The 3 treatment systems accounted for a 75% reduction in the amount of total suspended solids entering the lake. On the west side of the lakes are 2 30-inch surface intakes that outlet directly to the lake. The area around the intakes was enrolled in the Conservation Reserve Program. Above the seeding, grassed waterways were installed. This property is located within the city limits of Fulda. Across the highway is a fertilizer plant whose stormwater was crossing the road through 2 culverts, flowing across the field, and entering 2 open tile intakes that outletted directly into Second Fulda Lake. In August of 2000, the Watershed District purchased this property, replaced the open tile intakes with rock intakes, and seeded the 9-acre parcel into native grasses and forbs. The fertilizer plant placed a berm around their property to keep stormwater on site. 3 grassed waterways and a critical area planting were installed in 2008 on 3 severely eroded channels that enter a culvert, went under the road, and outletted directly into the lake. Through an Environmental Protection Agency Section 319 grant, the Watershed District offered incentives for landowners farming within the Fulda Lakes sub-watershed to practice conservation tillage. This graph illustrates the number of acres enrolled for 2008 through 2010. The second part of the 319 grant was to install 2 shoreline restorations. Because we did a lot of the work ourselves, we were able to do 4 restorations. They ranged from a simple 6-foot wide filter strip to reshaping and extensive landscaping. We also received a 319 grant to implement 5 rain gardens throughout the city of Fulda. We taught residents about stormwater and helped to create awareness of the effects of water pollution by engaging students, 4-H members, master gardeners, landscapers, and the general public. Murray County replaced the fixed crest structure at the outlet with a variable crest dam in 2008. The Department of Natural Resources installed an electric fish barrier. They also did a rotenone treatment on the lakes. Through an Environment and Natural Resources Trust Fund grant, the Watershed District installed a biodetention basin to provide treatment and flood storage by capturing 95 acres of overland runoff before entering the lakes. The next few slides shows the funds expended for these projects. The rotenone treatment and the electric fish barrier, the wetland restoration and the pond cleanout, the construction of the Murray County Pond, the rock inlet projects, and the purchase of the property within Fulda city limits, the grade stabilization structure, and the 319 grant for BMPs, the 319 grant for rain gardens, the Environmental and Natural Resources Trust Fund, for a total of a little over $460,000. This was the goal, and this is what Fulda Lake looks like. The Watershed District collects water samples on all major lakes within the watershed every 3 years. These charts show the average concentrations of total suspended solids in chlorophyll A from 1992 through 2016. Total suspended solids are a significant factor in observing water clarity. The more solids present in the water, the less clear the water will be. After the restoration work was completed, there was an 82% decline in total suspended solids. These solids include anything drifting or floating in the water, from sediment, silt, and sand to plankton and algae. Chlorophyll A is tested to determine how much algae is present in the lakes. Algae is important in lakes because it adds oxygen to the water as a byproduct of photosynthesis. On the other hand, if there is too much algae in the lake, it can produce a foul odor and be unpleasant for swimming. Following the drawdown, chlorophyll A declined 75%. Since 2006, chlorophyll A has continued to read at low levels. In 2009, after the drawdown, the phosphorus concentration spiked significantly. Shallow lake experts explain this to be because of the mineralization of sediment and breakdown of organic matter that occurs following a drawdown. When allowed to fill back up with water, the phosphorus is released in the water column. This is why there is a spike in 2009. Levels have dropped since then. And ultimately, the Fulda Lakes were removed from the impaired waters list. Thank you.